Today we're going to talk about two different types of data structures. The first is going to be a stack, the second is a queue, and we'll get into how they differ. So, looking at a stack first, so pretend that these are pancakes that we've made. And so 1 being the first pancake we made, 5 being the last pancake we made. And each time we made a pancake, we cooked it in a pan and then we placed it onto a plate. And so now we've got our stack of pancakes. And so, you know, the first pancake was made first. If we don't eat it, it's going to get cold because we spent time making 4 other pancakes. But I can't get to it. It's at the bottom of the stack. 5 comes off the stack first. This is where this term LIFO comes from. LIFO standing for last in, first out. Stack data structures are LIFO. So this 5th pancake has to be the first one out of a stack no matter what you do. You cannot remove this one element first, and the object there is stuck at the bottom of the stack. That's why it's called a stack. It's from top to bottom. Now a queue, on the other hand, is and let's use the office hours queue as an example. So we all know the office hours queue is stressful. So the office hours queue, if it were built like a stack, it wouldn't be fair. If the first person there was the last person to get helped, that first person there would never get helped. So instead, a queue is first in, first out. FIFO. So John gets to office hours first, and John signs up first. For the purposes of this, we'll assume that people can get to office hours and sign up, one at a time rather than like 100 people at once, like office hours sometimes are. So John signs up first, and then Mary comes and Mary signs up, and then Connor comes and Connor signs up. And then Professor running office hours goes, and the first person on the queue is John, and John gets served first. And that obviously is different than this first pancake that's getting eaten last. And so John gets help, and then Mary gets help, and then Connor gets help. And it's first come, first served. So you can see the difference here already is that it's like reverse order essentially. So if you enter objects into a queue, the first one you can access is the first one you put in. A stack, the first one you can access is the last one that you put in. And so why do we have these two different types of data structures? What might be the purpose be? Well, let's say, for example, that we're talking about Project 1, and you've got a treasure hunt going on, and you've got a captain and a first mate. And so the captain is trying to find treasure, and he is looking for treasure, and he thinks that the best way to go about looking for this treasure is to discover as many places as possible and then go to the one that you most recently discovered because you're physically closest to it. Well, the captain would want to use a stack. The stack would allow you to go to the place that you most recently discovered, look there. If you don't find treasure, move to the next one, the next one, the next one. The first mate thinks that you should discover all these places, but then go back to the first one you discovered and backtrace and move back to that first place that you discovered first, and then move on to the next place that you discovered, and so on. And so, if you're thinking about searching for treasure, the way that we are in Project 1, you can see that the solutions might be optimal at different times, and it really depends, and you're not going to know which one, but that's why the captain and first mate aren't in agreement all the time, and that's why we're going to build queue and stack data structures that work with both. So how do we build a data structure that can be either a stack or a queue? Well, we're going to use something called a deck. And a lot of people pronounce this DQ. It's not DQ, it's a deck. And a deck is essentially a double-sided queue. You can go from the front or the back. So if you're thinking about it, you can use a deck as a LIFO container or a FIFO container because it has both push front, push back, pop front, pop back functions. And so in Project 1, we're going to want to use a deck in order to implement both a stack and a queue at the same time. And then obviously you can figure out exactly how to use a deck for a stack and a queue. But the main thing that we want to take away here is that a stack is a LIFO container, a queue is a FIFO container, and the values of using them at different times.